The periodic table of elements is a tabular display tool used to identify certain elements. Students are generally able to read the periodic table but are often unaware of its objective structure and additional content. But don't worry, today I'll explain to you how to read the periodic table properly and effectively. This is a guide to read the periodic table. The periodic table is a very useful tool and for good reasons. For one, it displays everything you need to know about each and every element. Second, it generalizes similar elements in nature into definitive groups. And third, its elaborate framework provides a concise and collected arrangement in order. Let's get started. For all intents purposes, we will be looking at the International Union of Pure and Applied Chemistry, or IUPAC, and the North American Convention periodic tables. The IUPAC periodic table includes the numbering of vertical columns from 1 to 18 and horizontal rows from 1 to 7. Each of the horizontal columns categorizes what is known as an elements group or family. Each horizontal row refers to elements within periods or series. This structure is useful since we are able to coordinate what element belongs to what period of any group. Bromine, for instance, is located in period 4, group 17. Magnesium is located in period 3, group 2. When it comes to reading elements, the periodic table has a cell for each element. The periodic table usually consists of a legend, which represents info found in each cell used by the periodic table's format. Most cells consist of the element's atomic number, the element's name, and its elemental symbol. Sometimes, depending on what version of the periodic table you're looking at, the cell will offer more information. This includes the element's atomic mass, its electron structure by energy level, and the radioactive symbol if it is naturally unstable. Our periodic table includes all these arrangements, but note that other periodic tables may provide you with even more information. It is always important to understand its legend first, before reading each element. In total, there are 118 elements we can physically observe and plot down onto our periodic table. Every element's atomic number is numerically lined within periods based on their number of electron shells. Remember that an electron shell consists of sublevels, or subshells, which in return determine the capacity of electrons in their orbitals. The capacity of electrons an element possesses is notated in its electron configuration. The arranging order of electrons represent the amount of subshells, while the amount of said subshells represent the number of electron shells. The number of electron shells is thus equal to the principal quantum number, so for every period that begins, every element will jump to a new principal energy level. This in reason explains why periods are arranged from 1 to 7, since principal energy levels are arranged to their constraint. But what about group columns? Groups of elements belong in each column due to their similar physical properties. Groups stretch from 1 to 18 on the periodic table. This is a characteristic only found in the IUPAC format. The North American Convention includes Arabic numerals and a letter positioned above each column. This represents how many valence electrons each element within that column naturally consists of. This is proven when we look at the element's electron structure per energy level. The last energy level an electron accompanies is its outermost valence electron. If any element possesses only one valence electron, they will belong to column 1A. If any element possesses two valence electrons, they will belong to column 2A. Groups in the IUPAC format are usually color-coded to identify what group or family those elements belong to. Group 1, for instance, consists of pink color-coded cells that represent elements of alkali metals, while Group 2 consists of peach color-coded cells that represent elements of the alkaline earth metals. Groups 3 to 12 include the transition metals marked in orange. The inner transition metals are the elements separated from the table. The reason for this separation is entirely due to an unmanageable structure. The inner transition metals physically exist after Group 3 in place of Group 4. Because of its impracticality and the specifications of the inner transition metals, it is separated from the table and is not numbered appropriately. It should be mentally remembered, however, that the inner transition metals are always physically a part of it. Group 13 includes the boron family. You'll notice that this column contains two color-coded cells, green belonging to the metalloid family and yellow belonging to the post-transition metals. Since they both share similar physical properties, they are organized together in the same column. The same principle applies to groups 14 to 16, which consist of the carbon family of group 14, the nitrogen family of group 15, and the oxygen family of group 16. In all three of these groups, 3 color-coded cells are featured, including the nonmetals in cyan, the metalloids in green, and the post-transition metals in yellow. Group 17 includes the halogen family in aqua, and finally Group 18 includes the noble gas family in blue. It should be noted that any blank element not colored in is because they do not possess the physical properties to belong to any family, and are thus placed entirely according to their structure. With all being said, you should now be able to read the periodic table, but to read it effectively, you must understand term principles and other key concepts to consider what the periodic table is trying to convey. If you are unaware of what sublevels are, for instance, or the allowed amount of electrons per set sublevel, then most likely some information found on the periodic table will be of no help to you, or rather confusing. Coming to the table with an educated mindset, however, will provide you enough intuition to generalize ideas based on your own comprehension. The Aufbau principle, for example, can be applied with the help of this periodic table, since it relays its valence electrons for each element. You could even notate elements in their electron configuration with the help of the atomic number, which gives us a conceptual understanding to visualize an element's quantum structure. The periodic table aids most of the work students and scientists do in chemistry. Using prior knowledge and the ability to read the periodic table will allow you to effectively study these elements.